Hello everyone, today I will talk about Object-Oriented Programming or OOP for short. Then we'll compare to procedural programming. Then I will explain three basic OOP concepts, which is classes, an object, encapsulation, and inheritance. To make this easier, I will be showing images of short Java examples while explaining step by step. Let's start with our procedural programming example. In this procedural programming, I just created three variables for each grade, which is Math, Science, and English that has a value of 85, 90, and 88. I add them using int average and divided by 3 to get the average. This works, but if I had more students, I'd have to repeat this whole process many times. That's the weakness of procedural code. Now, in my OOP example version, I made a student class. It holds the grades of Math, Science, and English and has a method called getAverage that calculates the average automatically. Now, if I need another student, I just make another student object instead of rewriting the formula. That's cleaner and reusable. Now that I have shown you the difference between OOP and procedural, it's time for me to talk about the three OOP concepts, which will be classes and objects that I have already shown in my OOP example, and encapsulation and inheritance. Starting off with our first OOP concept, which is classes and object. Let's first create a class called game character. Then let's give our class an attribute, which is string name and int health, that store each character's state. Then we'll create a method void attack, this defining what happens when the character attacks. Now let's create an instance by calling game character in main, then giving it an object. Then we'll do it like this: game character hero equals new game character. This allocates memory and returns the reference to the new object, and the hero holds the reference so you can access its field and methods. Now, initializing the field. Right after instantiation, the object's field will have the default value, which is null for string and 0 for int. You assign the real value like this. So you call out hero, then dot name, so you can put value, which will call the hero name Luna. Then the health will be 100. Now, with fully initializing objects, we can call the behavior or method, which is the attack. So we'll use hero again, then that attack. This prints Luna attacks. Now that we're done with classes and object, let's start with our second basic concept, encapsulation. So in encapsulation, it's all about controlling access to data. So in this example, we'll create a class called Vault, and then we'll privatize the attributes, which is private int gold equals 0. Then create public void deposit parenthesis int amount. In this deposit, this is how we'll input how much gold we have or we want. Then create a method public int check gold. This will help us check our gold. Then create an instance which we need to call vault. Then the object will be v. Then we'll use v to call deposit. This will allow us to input how much gold we want. After that, we'll use system out print so that we can call out check gold, so it will display how much gold we have. And that's how encapsulation works. This keeps the data safe and avoids accidental changes. So now that we're done with our second basic concept, let's start with our third and last one, which is inheritance. What is inheritance? Inheritance lets one class reuse another. So that means you can use the method of one class and put it in another. So let's get started. So, in our parent class, we have class food. In our class food, we have a method or behavior which is void eat. Void eat says this food is being eaten. Now, okay, so we're gonna create another class so that we can extend food. So, class pizza extends food. We'll create another method in this, which is void add toppings, which says extra cheese topping added. That shows how we can reuse code while still adding specialized behavior. So, in here, we're gonna create another instance, which we'll call pizza. Then create an object, which is p. Then we'll use p to call eat and then add toppings. This will display those two behaviors. So to sum up our video, a quick summary is in order. So let's get started. Procedural programming defines a sequence of steps that operates on data. Each function performs a specific task, and data is often passed around globally. As projects grow, this approach can lead to repeated code and tightly coupled logic. While object-oriented programming, or OOP, organizes data and behavior into self-contained units called objects. Each object combines attributes with methods, which improves modularity and reduces duplications. So in conclusion, the benefits of OOP is its modularity, which helps group related code together, and reusability. Inheritance and composition enable developers to build new components from existing ones, and maintainability. Encapsulation enforces clear interfaces, reducing an unintended side effect when changing code. And the last one is scalability.